In 3,
would be better, but
2.
I can't do another one. Welcome to the Calculus 1 study guide for Dr. Lewis class spring 2015, part A and B. Brad.
So the question is, find a limit as x approaches 9 for the function here. So the first thing you do is attempt to find the limit by just plugging in 9. 9 minus 9. Zero over 0. And you can't have that. So the next thing we could try to do is make the function look differently. So and because this has a radical sign in the denominator, the best thing to do is to rationalize this function. And when you do this, you just keep what you have in the original function times this. And because you haven't plugged in anything yet, you want to keep your limit. Don't drop your limit yet. Over. Then you FOIL the bottom, so square root of x times square root of x is x. Square root of x times pi root of 3 plus square root of x. Then negative 3 times square root of x is this. And then negative 3 times positive 3 is 9. So these two cancel out, which leaves you with because nothing has changed in your numerator, and then in your denominator you just have x minus 9. And because these are the same, you can cancel it, which leaves you with because this just leaves you with a 1 in the denominator, and you don't need that. So now we're actually going to substitute 9 for x. So square root of 9 plus 3 plus 3. So your answer is 6.
The problem is finding the derivative of this function. The first thing you gotta do, you gotta change, put the x can't be in the denominator. So you gotta bring it to the top and minus 1, same thing with this one. The power rule, then the power rule, put this times this, minus 1. Power rule, same here. But the problem is they don't look like this. So you gotta bring this, the x, back to the denominator, which is
Number 3 says find the equation of the tangent line to y is equal to x squared plus x and in the parentheses they have 1, 2. So first you write the point slope formula, which is y minus y1 equal mx plus x minus x1. And then you take the derivative of y is equal to x squared plus x, which would be 2x plus 1. And then since your points are 1, 2, initial x1, initial y1, you plug in x1 into the equation, which would be, which is 3, and your slope is equal to 3. And once you find your slope, you plug it back into the point slope formula. Well, this will be 2. And then you solve, so it'll be y minus 2 equal 3x minus 1. And then, minus 3. And then plus 2 on both sides. And it cancels out. So y equals 3x minus 1. And that's your answer.
The directions was to find out what points this function was continuous on. So the first thing you do is set the denominator to not equal to 0. Solve for x. That's the answer, so you know the function.
Okay, so I have to take the derivative of e to the 5x plus sine 3x. Looking at this problem, you see you're gonna have to do the chain rule for both sides. So we're gonna cover up the 5x and bring down the e. And you're gonna bring your 5x right here. Take the derivative of 5x. And you're gonna do the same thing on this side, cover up the 3x, bring down the derivative of sine, which is cosine, and bring your 3x here, and take the derivative of the 3x on this side. That's going up, okay. So the derivative of 5x is 5. You're gonna bring that down right here, in front. And you're gonna keep 5 raised to the, you're gonna keep e raised to the 5x. And plus, bring down the derivative of 3x, which is 3, and bring down this cosine 3x. And that's your answer. So here we're going to find the derivative of x plus 1 divided by x minus 1. We're going to use the quotient rule, which is low d high minus high d low all over low squared. Low is the denominator, high is the numerator. So we're going to put x minus 1 times the derivative of the high function, which is x plus 1, minus x plus 1 times the derivative of x minus 1 all over low squared, which is x minus 1 squared. Then it's going to equal x minus 1 times the derivative of x plus 1, which is 1, minus x plus 1 times the derivative of x minus 1, which is 1, all over x minus 1 squared. Then we'll substitute in 0 because we have to find the derivative when x is 0. So it'll be 0 minus 1 times 1 minus 0 plus 1 times 1 all over 0 minus 1 squared, which will equal negative 1 times 1 minus 1 times 1 all over negative 1 squared, which will give you negative 2 over 1, which equals negative 2.
Function is x sine x, and this one you'll use the product rule. So x derivative of sine x plus sine x derivative of x. The sine of sine x is cosine x plus sine x derivative of x is 1. Now you'll plug in 0 into this function. So it'll be 0 cosine 0 plus sine 0, 1 equals 0, 1 times 1 plus 0 times 1 equals 0 plus 0 equals 0, and that's your answer.
Find the antiderivatives of x squared minus 2x plus sine x. So we use the antiderivative formula, which is x to the n. In this case, it would be 2 plus 1 over 2 plus 1 minus 2x, 1 plus 1 over 1 plus 1. And the antiderivative of sine x is negative cos x plus c, and we have c because this is an indefinite integral. So this will be x cubed over 3 minus 2x squared over 2, which we can simplify to b. We'll just erase this. X squared minus cos x plus c. Cosine of x plus c.
Woo, y'all, please give him a hand. Give him a hand. Give him a hand.
So number 9 is f of x is equal to x cubed plus 2x squared, and we're trying to find what interval does this concave up at. So the first thing you do is get your first derivative, which is 3x2 plus 4x, and then you're going to take your second derivative, which is 6x plus 4. And then you're going to solve for 0. So, 0, 4, and you're going to divide by 6, and then you're going to simplify, so it's negative 2/3. Okay, we weren't given a domain, so your domain is all real numbers. So, if I take this and put this here and then just choose 2 points on either side, point on either side, I can take those points and put it back into this equation and find out whether it's positive or negative. So 6 times negative 1 plus 4 is negative 6 plus 4, which equals negative 2. So going this way, any number going this way is going to be negative. So if I put the 0 in, 0 times 6 is 0 plus 4 is equal to 4, and that's positive. So since we didn't have a domain, we're going from infinity, negative, to our domain is negative infinity to infinity. So going this way, it's going to concave up. Which means the point or interval is going to be negative 2/3 infinity. The answer is D.
We're trying to find the limit as x approaches 1, and it's x minus 1 over x to the 4th minus 1. And the first thing we're going to go ahead and do is direct substitute. So wherever we see our x, we're going to plug in our 1s. So I'm bringing my equal sign because I'm plugging in my 1s right now. So 1 minus 1 and 1 to the 4th minus 1. And I'm going to go ahead and evaluate it, and this is going to be 0, and 1 4 times to the 4th is 1 minus 1, which is also 0. So we're left with 0 over 0, and we can't leave it like that, so we're going to exit out. Now we're going to go ahead and change how it looks. So we're going to rewrite our question again. So the limit as x approaches 1, x minus 1 over x to the 4th minus 1. So we're going to change how it looks. So we're going to go ahead and factor out this x to the 4th. So we're going to bring in x squared, because this is x to the 4th, plus or minus 1. And we can still go ahead and factor out again because this is x squared. So we're going to put x plus 1 and x minus 1. And I'm going to go ahead and rewrite it so you can see it. So since we changed the way it looks, we can go ahead, you can see that we can go ahead and cancel out the x minus 1 and x minus 1 from up here. And then we're left with this problem. And I'm going to go ahead and put the equal sign because I'm going to plug in my 1 now. So one minus 1, and we have 1 plus 1, and we have 1 squared plus 1. Since we cancel at the top, this is going to go ahead and be 1. And our answer is going to be, we're going to go ahead and simplify these. This is, sorry y'all. Our x's went up already. Yeah. So this is 1 plus 1, which is 2. And then this is 1 plus 1 again, which is 2. And we have 2 times 2, which is 4. So our answer is 1 over 4.